Example. Prove by mathematical induction 1 cube plus 2 cube plus and so on plus n cubes equals this. To solve this, we start with the first step, verification. When n is equal to 1, you substitute 1 in this equation. Therefore, we have 1 cube is equal to 1 over 4, 1 square bracket 1 plus 1 square. This implies that we have 1 is equal to 1 cube is 1, then 1 plus 1 is 2. 2 square we have 4. 4 divided by 4 we have what? 1. Since both sides are equal, you say, therefore the statement is true for n is equal to 1. We now move to the next step, which is induction. We assume that the statement is true for n is equal to k. You bring down the expression. You have 1 cube plus 2 cube plus and so on plus k cube is equal to 1 over 4 k square bracket k plus 1 square. This is equation 1. To prove that it is also true for n is equal to k plus 1. We bring down the equation. We have 1 cube plus 2 cube plus and so on plus k plus 1 cube is equal to 1 over 4 k plus 1 square bracket k plus 1 square. We name this equation 2. Now we are going to make use of this. Left hand side, we add k plus 1 cube to both sides of equation 1. Therefore, we have, this is equation 1. This, we are going to add both sides of equation 1 by k plus 1 cube. This implies that we have k cube plus, we add our k plus 1 cube is equal to 1 over 4 k square bracket k plus 1 square plus k plus 1 cube. We name this equation 3. If you see this is equation 3 now. You see that if you remove this, this is the same thing as this, and it's equal to this one here. So now we are going to rearrange this, the right hand side of this equation, to get this. Once we rearrange this equation, this right hand side, and get this, then we have proven that it is true for n is equal to k. Now arranging the right hand side of equation 3 to get the right hand side of equation 2. This is the right hand side. We have 1 over 4 k square bracket k plus 1 square plus k plus 1 cube. Something is common here. K plus 1 square is common to both sides, so we are going to factor out k plus 1 square. Now we have our k plus 1 square. What is left here when we factor out k plus 1 square? We have 1 over 4 k square plus k plus 1. This is what is left. This implies that we have k plus 1 square bracket. We are going to look for the LCM. K over 4 plus k plus 1. This is what we have. Now we look for the LCM of this. Have 4. 4 divided by 4 is 1 times k squared is k squared plus 4 divided by 1 is 4. Now we have 4 times k plus 1. This is equal to k squared plus 4k plus 4 all over 4. This implies that we have this. Bring it out. Have k plus 1 squared all over 1 over 4 bracket k squared plus 4k plus 4. This is the same thing as this. Now we are going to look for the factors of this. This is a quadratic equation. So if we factor this out, to bring out the factors, we are going to have k plus 1 squared bracket 1 over 4 plus k plus 2 squared. This is a factor of this. Let me show you how to get this. We have k squared plus 4k plus 4. This is the same thing as k squared plus 2k plus 2k plus 4. Got this here, got it here. What is common here? We have k. What is left is k plus what? 2 plus, we have what is common here? We have 2 then k plus 2. So the factors are k plus 2 squared. This is a factor of that. Now, remember, our aim is to get the right hand side of equation 2. Yeah. So we are going to arrange this to get this. Arranging this, we have 1 over 4, this one here, then k plus 1 squared, then we have k plus 1 plus 1 all squared. You see that this is the same thing as this. So we have gotten the right hand side of equation 2. That means the statement is true. Now we conclude. Since the statement is true for n is equal to 1 and n is equal to k, and also for n is equal to k plus 1, therefore the statement is true for all positive integers of n. This is the conclusion. So remember, when you have a question, mathematical induction, you want to solve it, first thing is you verify if the statement is true for n is equal to 1. When you substitute 1 in this equation and you get an equal number, if both sides are equal, it means the statement is true. Then step 2, which is induction. In induction, the first thing to do is we assume that the statement is true for n is equal to k. Now you substitute k in this equation, we have this, our equation 1. Since the statement is true for n is equal to k, it means that it is also true for n is equal to k plus 1. Then to prove that it is also true for n is equal to k plus 1, we bring down the expression. Then anywhere you see n, you put k plus 1, you have equation 2. Then in this equation 2, we make use of the left hand side. We add this k plus 1 cube to both sides of equation 1. Then we have our equation 3. When you write down the equation 3, you use the right hand side. We arrange this right hand side of equation 3 to get this. Because if we remove this equation is equal to this. So since this, when we arrange and get this is equal to this, it means that both sides are equal. It means the statement is true. Then we conclude, since the statement is true for n is equal to k, is also true for n is equal to k plus 1, therefore the statement is true for all positive integers of n. Thank you for watching. Remember, subscribe and share to all your friends.